Now third formula. Now we have to prove that dx upon x square plus a square is equal to log mod of x plus x square plus a square plus c. Now let integration of dx upon square root of x square plus a square. Now let x is equal to a tan theta now. Okay. Now differentiating with respect to theta, we are having dx is equal to a secant square theta d theta. Now let's put the values in the question. Now we are having integration of dx a secant square theta d theta upon square root of a square tan square theta plus a square. Okay. So now we are having integration of a secant square theta d theta upon a square common tan square theta plus 1. Integration of a secant square theta d theta upon a secant theta, and finally we are having integration of secant theta d theta. Now integration of secant theta d theta is what? Log mod of secant theta plus tan theta plus c1. Now x is equal to a tan theta, tan theta is equal to x upon a. Okay. Now using this term in our question, we are having integration of log secant theta tan square theta plus 1 plus tan theta plus c1. Now putting these values, we are having integration of log, now tan theta, already mentioned that tan theta is x upon a. It is x upon x square upon a square plus 1 plus x upon a plus c1. Is it clear? So now this becomes what? Log x square plus a square plus x upon a plus c1. Now this becomes log, we are writing like this, x square plus a square plus c1, and finally we are having plus c, where c is equal to c1 minus log mod a. Proved. This one and this one.